The general definition of a ring is very sparse and simple. However, particular rings may have optional features which make them a lot more versatile and interesting. So in this video, I want to look at some of these optional features and how they make a ring special. Let's start with the idea of a commutative ring. By definition of a ring, addition must be commutative, since every ring has an abelian group under addition. However, multiplication is not necessarily commutative. Whenever multiplication is also commutative in a ring, we call that a commutative ring. All of our main examples are commutative rings: Zn, Z, R, C, Q. Our modular arithmetic, our integers, our real, our complex, our rationals, even the function ring that I talked about before is a commutative ring. Next, let's talk about rings with unity. Rings with unity look at a multiplicative identity. So a ring does not necessarily have an identity element for multiplication. If we do have an identity for multiplication, that element is known as the unity, and we use the symbol 1 to represent it. So, a multiplicative identity or a ring with unity would have this element 1 such that a times 1 is a, and 1 times a is a for every a in my ring. And if my ring has this unity, then we call it a ring with unity. Next, I want to look at trivial rings. A trivial ring is a ring whose only element is 0. Non-trivial rings are then any rings with more than one element. And if we have a non-trivial ring with unity, then we must have that 1 is not equal to 0. So, provided our ring has more than one element, our multiplicative and additive identities cannot be the same. This is because if we did have that 1 is equal to 0, well, x would be, by definition, x times 1. X times 1 would be the same thing as x times 0 because I'm claiming 1 and 0 are the same, and I've already proven that x times 0 is 0. So I started with a random arbitrary element of my ring and got that it equals 0. So in other words, the only time 1 is equal to 0 in a ring with unity would be that every element in that ring is equal to 0. So 0 is the only element. It can only be a trivial ring. So provided it's non-trivial, if it has a unity, it cannot be the same as the additive identity. Now that I have the idea of a multiplicative identity, I can start to think about multiplicative inverses. So I must have a ring that has a unity element. It must be a ring with unity in order to talk about the idea of a multiplicative inverse. If we have a ring with unity, some elements may have a multiplicative inverse. It may not even be every element, but some elements may have this idea of a multiplicative inverse. These elements are called invertible. So in other words, we say that A is invertible if AX equal to XA is equal to 1 for some element X in my ring. As an example, if I consider my ring R of real numbers, then we have that every non-zero element of this ring will have a multiplicative inverse, since it would just be the reciprocal. On the other hand, if I look at my integers, the only thing with a multiplicative inverse would be 1 and -1, since reciprocals are no longer in the integers.